put two ratios together, set them equal to each other, you guys know that becomes a proportion. You have probably seen last year a variable in the proportion. How do you solve a proportion with a variable in it? Like, for instance, when we end up getting down here, how are you going to solve for n in a couple minutes? Cross multiply. Yep. Anytime I have two ratios equal to each other, I call it a proportion. To solve that proportion, we're going to cross multiply. And just to give you a little extra here, can I have more than two ratios equal to each other? Absolutely. That's called an extended proportion. All right. All right. What I want to get to today is how to solve it, and then you're going to end up factoring to solve a couple of them. All right. So go ahead, cross multiply for that one. I gave you guys just a basic one to make sure we're all good to go. You cross multiply, hopefully you're getting 5n equals 70. Divide both sides by 5, n's going to equal 15. Okay? Very basic, no big deal. Slightly advanced on number 2. What are you doing here with the 2 and the x plus 1? I know you're multiplying, but how? You have to do what with that 2? Distribute the 2. Okay? Distribute the 2. So 2x plus 2 equals 3x. And then I'll let you solve it from there. X equals 2. Any issues? I don't need to call on people here yet. All good? Any issues? Okay, let's move it on then. All right, now we get to Algebra 1 last year. Let me know what you get when you cross multiply. Okay, so cross multiply, and then I'll ask somebody what you ended up getting. Okay, 14. When you cross multiply, what do we end up with? There you go. X equals 6. All right, a couple things. And I know some of you may or may not have to do this. That's fine. That's why we're taking our time today. What is the highest exponent in that equation up there? The highest exponent. 2. Everyone, the highest exponent up there is 2. And you may not have been told this last year, but if you are solving the equation, whatever the highest exponent is, that's how many answers you should have at the end. Okay, I don't know if that's something new information to you, but I'm telling you now, whatever the highest exponent is, so right now it's 2, that means at the end you should have 2 answers for x. Okay, now that I've seen that the highest exponent's 2, I can't solve this unless one side is equal to 0, yes. All right, so that's probably what you're used to last year, getting one side equal to 0. So get the 6 over. X squared plus x minus 6 equals 0. And for you guys that are factoring beasts, I apologize for how slow I'm going, but I want to make sure we're all on board. How many terms does it have? 3 terms. That's called a trinomial. There are an a b, and a c value. Yes? What's my a value here? Which is the number in front of the x squared. What is the a value? The number in front of the x squared? 1. So if it's a trinomial where the a value is 1, you play a little game if you remember from last year. You figure out 2 numbers that multiply to c. So 2 numbers that multiply to -6, but at the same time will add to your b, in our case 1. All right, so multiply to your c, add to your b of 1. So I'll give you guys a second to think about numbers that multiply to -6, but when I add them together, it will give me 1. And then I'll ask somebody. Did we come up with those numbers? 18? -2 and 3. That looks like it multiplies the -6 and adds to 1. From here, what do I do with each of these factors? Okay, set them equal to 0. Some of you know the quick trick, which is just change the sign. So x equals +2 and x equals -3. How many answers did I get out? 2, just like we predicted, because 2 is the highest exponent at the beginning of the problem. So that's why I have 2 values here. All right, any issues? Okay, let's keep going. Can I still cross multiply even though it looks like this? Yeah, this is a ratio and so is this, but it's just not showing. It's over. There we go. So you're going to have x plus 6 and then multiplying that with x minus 6. So you're going to have to go back and double distribute. I'm not a big fan of the word FOIL. Double distribute. So I'll give you a second to double distribute and I'll ask what you have. So after you double distribute x plus 6, x minus 6, what are we coming up with? Here we go, 19. What are we coming up with? Okay. How about 15? And what happens to those two? They simplify each other out, and then the last term is minus 36 equals 13. Again, what's your highest exponent? 2, so you're going to have 2 answers, remember. Keep that in the back of your mind. I stress this in particular on this one. What do you want to do from here? I'll take anything here, anything. Go ahead, Sean. Okay, you want to set it equal to 0? That's fine. I'll show you a different method at the end. But yeah, go ahead. Let's move the 13 over. So when you move the 13 over, you get x squared. Go ahead, everyone. Figure -36 minus 13. Minus 49 equals 0. You are correct by saying it's not a trinomial, so I can't go multiplies to this and adds to this. But anybody know anything about the number 49? It's called a perfect square, yep. So you can do a method you learned last year called difference of 2 perfect squares. Difference of 2 perfect squares. You still have x and x, but 49 is a perfect square for what number? 7, yep. 7 and 7. And anybody remember this method last year about the signs? Always opposite. Always opposite when it's the difference of 2 perfect squares. Yep. X equals 7 and x equals -7 for my answers. Okay, hold on here. I don't need you to write this down. I just want you to focus up here. When I asked Sean what he wanted to do, he said move the 13 over. Fine. He could have also said add 36 over. And when we would have done that, it would have been x squared equals 49. And what would he have done on both sides then? Square root. And this is where I get nervous, you doing it this way, because a lot of you would have just said 7. Again, how many answers should I have? 2. That's only 1. Because when you take the square root of a number, you are left with the plus or minus version. Is everyone used to this symbol here? Plus or minus, because I'm going to use it on Monday a lot. We're okay there? Okay, so if you decide to do it this way instead, just remember, you got to have 2 answers. So it's just not +7, it's got to be -7. All good before I get into another way of factoring. All right, let's keep reviewing all the different ways to factor with number 5. Cross multiply for me, please. Cross multiply. What do you end up with? 14. What do you end up with cross multiplying? Okay, I'm good. Hey guys, how many answers are we going to have at the end? Yeah, 2. Keep that in mind. Because if you're leaving one answer, you're missing one. All right, we still got to set it equal to 0. I always like to have my whatever's with the x squared, I love to have it positive. So I'm going to keep this 2x squared there, move the 12x over, and set it equal to 0. How many terms are up there? 2. So you can't do this little multiplies to this, adds to this trick we did up in the first one. Not going to happen. It's not the difference of two perfect squares. None of these are perfect squares. So this is probably the first method of factoring you learned last year in Algebra 1, which is look for something in common. GCF method. 2x squared minus 12x. What do they have in common? A 2 and anything else in common? An x. I can take a 2 and an x from both of those. And that's exactly what I'll do. Is I'll take a 2 and an x out. It doesn't go away. It stays right there. I'm going to kind of do reverse distributive property here. What must have been inside the parenthesis for me to get 2x squared minus 12x? So here you go. I had 2x squared, but took out a 2x. What's still remaining from this? An x minus I had 12x, but I divided out a 2x from it. 6. Still remember, how many answers should I have? Still should have 2 answers because I'll get this answer right away. X equals 6. I'll get that one. But then I won't see the other one anywhere. And where do I get the other one from? You get the other one from your GCF you took out. What was the GCF we took out? So I still have to set that equal to 0 and solve it for x. That's how you get your second answers, by setting your GCF equal to 0. And what are you going to do on both sides there? Divide by 2, divide by 2. So the other answer should be 0. Yep. That's how you get your second answer, by setting your GCF equals to 0 and solving. Any questions there? Well, we got a couple more there. All right. You know what? I'm going to let you guys go on your own here. I'll let you go on your own, and then we'll have a couple people tell me what they did. If you want to work with other people in your group, go right ahead. But let's see what this is a good opportunity for you guys to try these out on your own. And I can't, if you're struggling with this, I'm not spending all unit on it. All right, we're spending today and Monday on this. So if you're struggling with the multiplying, the factoring part, get in here. X squared minus, you're distributing, right? So what's x times -2? Now bring all that over, right? Because you didn't have the 2x there before, so that makes a huge difference. Two numbers that multiply to what? Negative 12, but add 2. That's the number out in front, 1. So two numbers that multiply to negative 12, but add to 1. Are we getting to... Okay, that's fine. Just try to write it in the order. So plus 4x plus 3, because I think that's what's you're getting fooled with. And then you can bring the 3x and the 15 over. It's got to add to what's your b value here? 1. So do these two add to 1? So it can't be those two. It's got to be another pair. Okay, ready? What was your b value? Yep. So two numbers that multiply to what? No, it's your c multiplies to your c value. What's your c value? Negative 30, right? So you're looking for two numbers that multiply to negative 30 and add to negative 7. Okay. You guys can feel free to move on to the homework. I'm just making sure if I need to help anybody individually here. Okay, hold on, Max. How do we get the 15 here? 3x, and then, okay, how are we getting this right here? Because you're multiplying those two, right? So you got to do x times 3x, 1 times x, 1 times 3. You got to do that double distributing. Okay. Are you familiar with that, or? Yeah. Okay, because you get more than what you had. You forgot to do 1 times 3. Okay.